Welcome to Write a Byte. Today we're building a CQRS Fhir app with Copilot. Hopefully it won't be trivial. Well, what is CQRS? CQRS simply stands for Command Query Responsibility Separation. A command refers to what to do. A query defines what list of things to do it to. Responsibility separation means they are decoupled. An example of CQRS would be adding a list of items to a grocery cart. It could mean querying for a list of tickets in your backlog that are older than 6 months and deleting them. Here's the holy equilateral triangle of coding, TM. First we write the code, then we test the code. Then we check and see if it's right, and if it's not, then we write the code, we test the code, we check and see if it's right. If it is, we move on to the next step, and rinse and repeat. One of the big ideas of using Copilot is that it gets us out of a code writing workflow and into a code reviewing workflow, which is similar to writing code, but with more reading. Here's the holy equilateral triangle of programming with Copilot. First, we're going to prompt Copilot. Then we're going to review Copilot's output, see if it's right. If not, we'll reprompt Copilot. And if it is right, we'll move on to the next step. Very similar to what we were doing before. Here's how we'll be reviewing Copilot's changes, because you can't always trust what it says it did. Starting in the top left corner, we'll have a clean Git status, meaning we have no uncommitted changes. Then we'll apply Copilot's changes. We'll review the diff, and then we'll commit or roll back. Committing frequently is important because we're going to be making multiple file edits at once, and committing frequently helps us not to lose work that we would like to keep. Here we are in Visual Studio Code. We're going to be doing something that a lot of people don't use Copilot for, which is generating a new project. We're going to ask Copilot, can you generate a new React application which uses Vite for bundling and uses Tailwind for styling? Now here's the step-by-step instructions. So we have a bunch of commands that were output. One of the cool things about Copilot is you can actually run the commands in the integrated terminal. Looks like we have to install our dependencies. We'll install Tailwind, init Tailwind, add a config file for Tailwind, and we should be good to go. So let's follow these steps. We'll click the terminal icon. I'll pull up and run these commands. We'll say yes. We'll scroll down to React. We'll do TypeScript with the speedy web compiler. And there we go. At this point, we should probably rename the project. So we'll do mv my React app to Fhir CQRS. And we'll cd in there. We'll do an npm install. Okay, it successfully installed all the dependencies. And now we'll install Tailwind by doing the same thing. We'll click the terminal icon and run. All right, we're good to go. Next thing to do is run the Tailwind init command. Awesome. And now we need this Tailwind config file, which this has an apply an editor command, which when we click, we see to apply this code block, open a code or notebook editor. So we're going to create a new file here. We're going to open the folder that we just created, Fhir CQRS, and there we go. Yes, I think I trust the authors. So now we have to make a new file. Notice that we lost our context. That's okay. We can ask it the same prompt and hope that it does the same thing. And as you can see, it's generating very similar output to what was generated before. Now we need to create the CSS file named styles.css. Once we have that, we can apply the changes in the editor. We can accept the changes, delete the comment, we're good. Now we can create the Tailwind config.js. If we just click this, when you see this icon, it'll just create the file. Then once the file is created, same thing, you can just apply the changes in the editor. At this point, you may be wondering, why did Copilot generate a bundling step for the CSS? Doesn't Vite do that? The answer is yes, Vite does do that. However, remember when we opened a new project and lost the Copilot context? At this point, Copilot only knows that we have two open files, styles.css and tailwind.config.js. It doesn't know that we are in a React application using Vite. So these steps are not necessary. To test Tailwind, let's open up our app.tsx. And now with this Copilot, we'll ask Copilot, Can you adjust this file to use Tailwind classes? And we can see with these class names that these are all Tailwind classes. We'll apply the code block, check the diff, and accept. Let's see if it worked. We'll toggle our terminal. Run npm run dev. And look at the website. And ooh, we got an error. Remember when we were generating the bundling options and how it didn't have the Vite context? That's likely causing some sort of an issue. So instead of Googling or Stack Overflowing this, we'll just copy this and just paste it in Copilot, saying, getting an error. Paste the stack trace. And notice that it said app.css. Let's open that file so that it has context. And as it's generating, there's one thing that's standing out to me, and that's that it's not mentioning anything about Vite, which means this is likely wrong. We've already done many of these steps. So instead, we may have to reprompt. Here's a prompt I used that is very similar to the last one. For some reason, this time, Copilot told me to update the Vite config.js specifically to import React using the plugin React. The rest is largely the same. When I did this, I had an error that said can't find module, so I did a simple npm install, and it worked. So let's go to our browser and see what it looks like now. And it worked. We'll go to inspect to see if our Tailwind classes are properly being applied. Everything's centered. We see justify center applies justify content center. That's a Tailwind class, as is flex. Looks like everything's good. So now we've properly scaffolded everything. We can actually start to code. To begin, we'll ask Copilot, I'm building a CQRS application for Fhir data models. How should I approach this problem? And Copilot's generation has a lot of things that we can use to understand our problem better. This will help us code in the future. The steps give a brief introduction on what CQRS and Fhir are, how to set up the project, which we've already done, define Fhir data models, set up command and query handlers, implement command handlers, implement the query handlers, set up the event sourcing, which is optional, add a database, add an API, and add testing. To begin, we'll ask Copilot what packages we should use for the data modeling for Fhir. Since I only care about the types, I'll just choose the types for Fhir. Now let's open our app.tsx. And ask Copilot, can you show me how to render two data models using the types Fhir package? So it's going to choose patient and observation. Since Fhir is a national standard, Copilot understands how to use commonly used libraries with it because it has the context. We'll apply these changes and see what it gets. Of the changes, we have a useState directive. We've defined a patient from the types Fhir and an observation. You can also see that we have an error rate here that says that this is not a module. We should be able to fix that using fix using Copilot. It says we should import the types from the Fhir package instead of types Fhir. We'll accept that, and there you go. We'll save the file and go back to our browser. We'll find the header fragment, starting with this div with the Vite logo, and just scroll down until we find the appropriate end tag. Right here's where we start with the patient data. Delete all that and save. And now we can see that's gone. Let's now ask Copilot if it can render a table of either observations or patients and filter based on common properties. We'll ask Copilot, can you create a table that renders a list of patients or a list of observations? Use a dropdown to choose which model is active. See, it's defined a few test patients and a few test observations. And then it's determining based on the active model whether or not, if it's patients, then render this table. And if it's observations, render this table. This is a little bit clunky because patient and observations are two disparate models that have no unifying view model. So we have to do branching in our view logic, which is a little bit awkward. Let's ask Copilot, can you update the previous example to use a view model for both patients and observations that dictate the columns? It's going to define an interface for column, define patient columns with a bunch of accessors that have an anonymous function that take a patient and return a property. And same thing for observations. Now by using a view model, it'll be able to render both patients and observations without branching in the view logic. Let's apply the changes and see what we get. So let's take a break and kind of see what's been done so far. We notice that the model that's active is defined using this useState hook, patients or observations. Now let's see where this is being used. I'm going to see where else active model is being used by searching for it with the asterisk from Vim. We see that we're defining the columns and data based on which the active model is and that this is an incoming change. Let's accept that. Then here, we'll render the name of the active model in an H2 tag. And let's accept the interface changes. All right, not bad. Let's see what it looks like. Oh, looks like our Vite and React came back. We likely didn't clear the context properly. We can take care of that in a second. For now, let's check and see if the table works as expected. Looks pretty good. And here's what the table looks like without that Vite or React again. Now we should figure out how to add some filters. We'll ask Copilot, we'd like to add filtering capabilities. We need the ability to select the header to filter on, select a predicate for the filter, and a function to apply the predicate to the active model. Let's apply, and let's check out the changes. So it implemented two predicates, equals and contains. That's a sensible place to start. It added the necessary hooks to manage the state for what filter was active. And here's the predicate function. And here's where you have to be a little bit careful about just blindly accepting Copilot's responses, because this is right. However, notice what it's actually doing. It's doing a data.filter, which is going to iterate over every item of data we have. And then it's going to do a find within the filter, which is going to be a nested find, so it's a big O of n squared. This is probably fine for small tables like what we have. But with larger tables, this could be a performance hit. It might be better to access something directly with a map key. But that's not the data that Copilot had to go on. So this is what it came up with. Then lastly, it's doing branching inside a single function. Again, fine for two predicates, but as we add more and more predicates, this function is going to get really ugly really quickly. It might be better to have a map that dictates which keyword equals, contains, like, etc. maps to what predicate function. But at any rate, let's see how it looks. The v header did sneak back in, so I'm not entirely sure why the context still thought that was relevant, but I manually deleted it. Let's test the filter. We'll select ID predicate equals filter value 1. Sure enough, it only shows up John Doe. If we say 2, Jane Smith. Let's try contains. We'll select the filter as gender. We'll try contains AL. What if we type ALE? What about if we type ALEE? What if we type in female? How about male? Seems to work. Let's try it with observations. Let's try the code. There we go. Seems to work. Now that we have a dynamic table that can render multiple data models, we need to serialize the filters so that our query can go over the wire and hit our API. So we're going to ask Copilot, we need to serialize the filters so that we can query our API. Can you show an example of how to serialize these filters into a parsable string? Notice that Copilot's actually hitting the API, or hitting an API that hasn't been written yet. We should ask Copilot to not use this change. Instead, we should have it just print the serialized filter in the query string. Here's Copilot's explanation for what it's actually doing to achieve this. Understanding the explanation is arguably more important than just copying and pasting code. Otherwise, your code will not be maintainable long term. So let's see how Copilot chose to serialize the filters. It's defining 3 variables: filter column, filter predicate, and filter value, and appending it to the locally defined params. Then, the use effect right below it depends on filter column, filter predicate, and filter value in the dependencies array, meaning when any of them change, this effect will be run. We'll get the query string by calling serialized filters, and then we'll set the new URL equal to window location path name plus the question mark and then our query string. Finally, we'll set the URL by calling window.history.replaceState with the new URL. Let's see if it worked. We'll select the column ID, predicate equals filter value 1. And we can see it's updating the query string in the URL. That ends part 1. Let's review. Using Copilot, we learned about our problem domain, learned about relevant libraries and installed them, reviewed code, learned about Copilot's approach, and made adjustments. There's one word that keeps on showing up. Can you figure out which one it is and why it's important? Copilot is about learning.